Welcome everyone to this second Pufendorf lecture with Professor Brandom. For those of you who missed the first lecture, I want to mention that there will be the lecture will be about an hour long, and it will be followed by a Q&A. People attending here in Lund will be prioritized when asking questions, but I'm hoping that we can we'll have time for questions from our remote viewers as well. If you're attending remotely and want to ask a question, please post your question in the chat, and I'll activate your microphone during the Q&A. Please state your questions succinctly, as there may be others waiting their turn. And note that since the questions will be recorded, please do not post one if you don't want to be recorded. All right, let's get started for the second lecture. Round of applause.
Thank you very much. So my topic today is logic, and I'm well aware that not all philosophers care about logic. Indeed, my beloved Dr. Vater Richard Rorty used to claim that he remained convinced that nothing of any philosophical significance had ever happened within 6 feet in any direction of a quantifier symbol. I hope that that extreme view is not widely shared. But I want to talk about why logic is important for thinking about reasons, as in part as a way of thinking about logic, and in part as a way of thinking about reasons. But I want to say that logic isn't what you think it is. It's not for proving stuff, it's for saying stuff. I'm interested in the expressive capacities of logic, their capacity to make reason relations explicit. So here's the elevator pitch version of the talk I'm about to give. Last time I introduced an important concept, thinking about reasons in terms of reason relations. Today, I want to talk about their structure. Is there anything general to be said about the structure of reason relations as such? Well, we know the structure of some reason relations of implication and incompatibility, namely logical consequence and logical inconsistency. And we know what the structure of those reason relations is. The trouble is that most reason relations sort of in the wild, the ones that articulate our actual non-logical concepts, don't have that structure, the structure of logical consequence and inconsistency. So what is the relation between logic and reason relations? And I'm going to be developing a view of logical expressivism that says that the task of logical vocabulary isn't to determine what's a reason for what, but to make antecedent reason relations explicit. But even there, how can we do that given the mismatch of structure between logical reason relations and non-logical ones? If we rethink logic, what do we want from logic in an expressivist mode, we'll find out that there is a logic that can express even substructural reason relations. And it turns out that logic has some other remarkable properties, and it's more familiar than one might have thought. So, end of the breathless sketch. In my first lecture, I introduced the concept of reason relations, of implication and incompatibility, motivated by Harman's argument for the need to distinguish such rational relations from inferential practices. And I showed that such consequence and exclusion relations can be understood as amphibious between pragmatic accounts of what one's doing in using declarative sentences to say something in the sense of asserting or denying it, and semantic accounts of what one's saying, the proposition being accepted or rejected on the side of meaning. According to a bilateral, two-sorted normative pragmatic theory, for the premises gamma to imply the conclusion A is for anyone who accepts all of A to be precluded thereby from entitlement to deny A. Who accepts all of gamma. And in that sense, to be implicitly committed to accept A. According to the modal mereological truthmaker semantic theory, for premises gamma to imply the conclusion A is for every fusion of truth makers of all of the propositions in gamma with falsity makers of A to be impossible states. On the basis of Floebel's pragmatic semantic isomorphism result, I invited us to think of these two very different kinds of discursive metavocabulary as offering a stereoscopic view on one single topic, reason relations. The very same relations of implication and incompatibility can be understood both in deontic normative terms, of which constellations of doxastic commitments are inappropriate in the sense their interlocutors can't be jointly entitled to them all, and in alethic modal terms, of which fusions of sets of states, truth makers and falsity makers, are impossible. The idea is you've got on the semantic side alethic modal connections that say the coin's being made of copper is incompatible with its being an electrical insulator, and it necessitates that it would melt at 1,080 degrees centigrade. Those are alethic modal facts. But it means that the claims, the coin is made of copper, and the claim, the coin is an electrical insulator, are incompatible in a normative sense. It's not impossible to commit yourself to accept both. It's just you can't be entitled to both. And similarly for the implications. This is what I called bimodal conceptual realism about reason relations. This thesis and the pragmatic semantic isomorphism that justifies it articulate an understanding of the bilateral distinction between practical doxastic attitudes of acceptance and rejection and the bivalent distinction between semantic values of truth and falsity. We see those as manifestations of a single basic discursive bipolarity. Shows up in one way on the pragmatic side of use, in another way on the semantic side of meaning. After all, doxastic acceptance of a claimable content of the sort paradigmatically manifested in speech acts of assertion is practically taking or treating that content as true. So acceptance and truth are connected. And doxastic rejection of a claimable content of the sort paradigmatically manifested in speech acts of denial is practically taking or treating that content as false. Those relations at the level of sentences between pragmatic attitudes and semantic values are platitudinous and not controversial. What is controversial here at the level of sentences is whether either a pragmatics first or a semantics first order of explication is possible. Whether one or the other set of opposed metaconcepts, acceptance, rejection on the pragmatic side, truth, falsity on the semantic side. The question is, can you make sense of one or the other of those, the pragmatic or the semantic, independently of the other, so that there's an explanatory route from the one to the other? I want to start off today by suggesting that we're not going to adequately understand these two manifestations of this basic semantic bipolarity if we remain at the level of sentences and think about acceptance, rejection, and truth and falsity. That same bipolarity necessarily shows up at the level of reason relations among sentences. And I think looking at the way it does teaches us something about that basic bipolarity. One form that it takes at the level of reason relations is the distinction between relations of implication and incompatibility. But the connection between that distinction and the paired distinctions between acceptance, rejection, or truth and falsity are, to say the least, not obvious. But the line of thought I've been developing locates the structure common to bilateral pragmatic metavocabularies and bivalent semantic metavocabularies at this higher supersentential reason relational level. And that's what I want to start by saying something more about. The structural and functional connections between the sentential true-false and accept-reject dyads on the one hand, and the reason-relational implication-incompatibility dyad on the other, are subtle and not obvious. We can begin to make those connections visible by thinking about the relations between classical bivalent truth values that make it possible for them to play their appointed role in semantic theory. First, there's two truth values. There's two different truth values. Second, they're not merely different, they're exclusively different. True and false function like incompatible properties, at least contraries like square and triangular, not like compatible, merely different properties like square and red. Late in the game, we might consider relaxing the prohibition on something being both true and false, and actually tomorrow I'll have something to say about that. But the original bivalent conception forbids overlap of extension between true and false propositions. The fact that if it's true, it's not false. If it's false, it's not true. That's baked into the distinction between the truth values of true and falsity as part of what's required for them to perform their job. Even fine, sophisticated truth-maker semantics retains that basic structural feature via his exclusivity condition, that any fusion of truth makers of a sentence with falsity makers of the same sentence must be an impossible state. So they strongly differ from one another. That expresses his modal reading of the incompatibility of truth and falsity. On the pragmatic side, there's a corresponding normative prohibition on accepting and rejecting the very same claim at the very same time. You can do that, but you can't be entitled to those commitments. What I want to say is that there's a deep connection between the shared exclusivity feature of truth values and exclusivity of doxastic attitudes, construed on the one hand in alethic modal terms and in the other in deontic normative terms, on the one hand, and reason relations of incompatibility of claimables on the other. So I claim this is a subtle but important fact that it's essential to the oppositions at the sentential level that the truth values or the attitudes be exclusive of one another, that they be incompatible with one another. And here we see a connection between those properties at the sentential level and the reason relation of incompatibility. But now, this exclusiveness or incompatibility, both of paired truth values and paired doxastic attitudes, it's a symmetric relation among them. In the book, we actually give an argument of why this needs to be true. I'm not going to go into that. But that relation of exclusion doesn't privilege truth over falsity or acceptance over rejection. But in fact, if we think about the explanatory role that the truth values and the paired attitudes of acceptance and rejection play, we see that there's an important asymmetry between them. You can't systematically swap falsity for truth or truth for falsity while preserving the applicability of a semantic theory. Truth and falsity are not just different and incompatible semantic properties. There's some vague, hard to articulate sense in which truth is the good one. It's the one we want or prefer. And something analogous is true on the side of pragmatics. Practical attitudes of acceptance and its manifestation in speech acts of assertion have a certain pragmatic priority over attitudes of rejection manifested in speech acts of denial. While it might be more difficult to articulate just how acceptance is pragmatically privileged relative to rejection, it is intelligible as a priority of taking true over taking false. The key claim I want to make here is that the sense in which truth is primus inter pares, first among equals, relative to falsity in the classical bivalent understanding of truth values, is that it's what's preserved by good implications. The reason you can't systematically swap falsity for truth while preserving a functioning semantic theory is that falsity preservation doesn't yield a usable notion of implication. There's subtleties there, but that's the basic claim. What privileges truth over falsity is that a good implication that has true premises has true conclusions. It's the relation to implication that privileges one of the truth values over the other. This way of looking at things explains how the distinction among reason relations between incompatibility and implication can be seen as to be a species at a higher level of the same genus of basic discursive bipolarity as the distinction at the level of sentences between truth and falsity on the semantic side and between acceptance and rejection on the pragmatic side. Incompatibility relations capture the modally robust, symmetric exclusion or repulsion aspect of the basic bipolarity, which is common to the semantic and pragmatic oppositions between true-false and accept-reject. In the classical setting, implication relations explain the non-symmetric privileging of some sentential truth values over others. Truth is the property of sentences preserved by good implications. Further, I think this line of thought gives us reason to think of the version of the dichotomy at the level of reason relations as, in an important sense, more fundamental than the version that shows up at the sentential level. For this account articulates the meta-conceptual relational features of bivalent truth values that explain their meta-conceptual capacity to express important properties of sentences. I mean, their exclusion or incompatibility with one another and the asymmetric privileging of one or another. I originally introduced the concept of reason relations, of implication and incompatibility, as normatively governing which doxastic commitments count as reasons for which others and which count as reasons against which others. For instance, these are reasons to accept and reasons to reject, forwarded in justificatory defense of and critical challenges to doxastic commitments. I've claimed and lightly argued that we won't be able to properly understand the semantic and pragmatic properties of sentences that exhibit the basic bipolarity of true, false, and accept, reject, unless the story includes reason relations of implication and incompatibility. And we saw last time that there's a robust bimodal isomorphism between pragmatics and semantics that also holds at the level of reason relations. Together, these considerations give us reason to look to reason relations in order to understand the truth evaluable, acceptable, rejectable contents that are expressed by declarative sentences, which are what stand to one another in the relations of implication and incompatibility that I'm claiming are amphibious between what's specified in the bilateral pragmatic and the truth maker's semantic metavocabularies, each of which exhibits its own version of what I'm calling the basic discursive bipolarity. Because the very same reason relations can hold both in the pragmatic and semantic settings, we can consider what kinds of things stand in those relations just insofar as those relations are shared. This will be the rational or conceptual aspect of propositions, which can be specified in these two quite different ways. Because they stand in reason relations, I'll call the relata rational propositions when they're specified in terms of their role in reason relations alone. Their functional roles, these very different kinds of items, sentences and worldly propositions, can play with respect to the potentially shared implications and incompatibilities. We needn't go so far as to identify truth-evaluable sayables and claimables with those roles in reason relations in order to investigate the rational dimension of such propositional contents in the sense of the aspect or dimension of content that consists in their playing that role in reason relations. I want to call that specifically conceptual content. In my third lecture, I introduce a pure, formal, model theoretic semantics of propositional conceptual roles in this sense, implication space semantics. It's pure in that the only resources it draws on are the reason relation items in a lexicon of sentences stand to one another, according to what in the first lecture I called a vocabulary. A vocabulary in that sense is a relational structure that consists of a domain and a set of relations on the domain. In the basic case, the domain is a lexicon of sentences, and the relations are reason relations among the sentences in the form of pairs of sets of sentences. So construed, vocabularies abstract away from the bilateral pragmatic and the truth-maker semantic account of what makes implications good. They each have explanations of what you're saying when you say that implications or incompatibilities hold, but we can abstract from that. The vocabulary just specifies which consequences among sentences hold, ignoring why or in what sense they do. Remarkably, we'll see that those spare raw materials suffice for an expressively powerful and flexible formal model theoretic representation of the conceptual roles played by declarative sentences. So the top-down order of explication that I'm pursuing, which appeals to relations of implication and incompatibility in order to understand the propositional contents expressed by declarative sentences, faces clarificatory demands concerning the structure of reason relations that traditional bottom-up orders of explanation don't face. In Fine's truth-maker semantics, for instance, the structure of consequence relations is determined by and inherited from the modal and mereological structure of propositions, just as in earlier views, consequence relations were read off from the truth conditions of the sentences that show up as premises and conclusions. What considerations specifiable at the level of reason relations do put structural constraints on implications and incompatibilities? Well, we've seen two so far. To begin with, reason relations must come in two flavors, corresponding pragmatically to reasons for and reasons against, reasons entitling interlocutors to accept and reasons entitling interlocutors to reject doxastic commitments. I've argued that we should think of this bit of structure as the manifestation at the level of reason relations of the same basic discursive bipolarity that shows up in traditional semantics as the distinction between truth and falsity, and in bilateral pragmatics as the distinction between acceptance and rejection. I claim, all right, what further structural restrictions might the meta-theoretic role envisaged for reason relations impose on consequence relations? We want to assume nothing about the structure of the bearers. What considerations could be appealed to in imputing a structure to consequence relations as such? From the point of view of a top-down implication relations to sentential contents order of explication, it's perhaps surprising that the logistical tradition has a well-defined, widely agreed upon answer to this question. What's the structure of reason relations? Even though that tradition is not at all pursuing the project that motivates me here to ask this question. A century or so ago, in the 1930s, Tarski and Gensen, the founders respectively of the model theoretic and proof theoretic traditions in logic, put forth basically the same proposal for necessary and sufficient structural conditions for relations among sets of sentences to qualify as genuine consequence relations. Their official topic was specifically logical consequence relations. But unlike, their characterization of the required structure didn't appeal to internal logical structure of the sentences that stand in consequence relations. Indeed, Tarski sometimes omits the qualification logical, and refers to his topic just as consequence relations. And Tarski's view is that what's essential about consequence relations, relations of implication, is that they correspond to topological closure operators. In our terms, he takes a vocabulary to be a lexicon L of sentences and a two-place relation between sets of sentences, pairing each subset X in the language with its consequence set, con of X, as satisfying three conditions. Containment, that among the consequences of any premise set are to be found those very premises. Monotonicity, that if one premise set is a subset of the other, then the consequence set of the first is a subset of the consequence of the other. Adding new premises doesn't lose any consequences that you have. And idempotence, that the consequences of a premise set are already consequences of the premise set. These are all principles concerning the structure of implication relations. They address only the role that sentences play as premises and conclusions of implications, regardless of what internal structure these sentences might or might not have. That is, there's no specifically logical vocabulary involved yet. The closure principles articulate a structure common to the consequence relations of traditional logics. For instance, classical logics, modal logics, intuitionistic logics, they all agree on these structures. And they hold of the reasoning in mathematical proofs. Those virtues are sufficient to confer some plausibility on the claim that the topological closure conditions specify necessary and sufficient conditions for a binary relation between sets of sentences to qualify as a genuine consequence relations. And there are at least two principled reasons one might accept such a definition. First, you might take it that consequence just means specifically logical consequence. That's the claim that genuine reason relations are always at base logical reason relations. Implication is logical deducibility, and incompatibility is logical inconsistency. Behind such a definition is a view, logicism, about reasons. That's the view that in the end, all good reasons, whether for or against, must always be logically good reasons. The Tractatus is the purest example I can think of such an account. And I think not many contemporary philosophers would defend this sort of universal logicism about reasons, even as properly restricted to doxastic rather than practical reasons. A weaker fallback position is what could be called structural logicism about reasons. It acknowledges that some good implications might not be logically good, but it insists that even material, non-logical consequence relations must share the topological closure structure of logical consequence relations on pain of not qualifying as consequence relations in the sense that has normative significance for reasoning practices. But that can't be right. Oops. Sorry. Better I do it this way. In spite of the considerable weight of authority and tradition behind treating topological closure structure as a necessary condition for genuine consequence relations, the stubborn fact is that outside the artificial formal languages of logic and mathematics, a lot of actual reasoning conducted in natural languages is defeasible rather than monotonic. Premise set gamma can imply A, even though there are further sentences we can add to gamma that would result in a premise set that no longer implies A. This sort of defeasibility, it's of evidence the status of reasons as merely probative rather than necessarily dispositive in support of a conclusion is ubiquitous in rational practice, even in the most institutionalized context of reasoning, such as law or medicine. Non-monotonicity is also a familiar feature of probabilistic reasoning, where new information can change the relevant reference class with respect to which frequencies are assessed. I say, well, I picked an elephant from the herd at random and weighed him, so probably his weight is close to the average of the average weight of the herd. Yeah, that's a good implication. If I add the premise, yeah, and the elephant that I picked randomly was Jumbo, the biggest one in the herd, now it no longer follows that his weight is probably the average of the herd. Nor do speakers cite defeasible reasons just for convenience, because it would be too tedious to include all the provisos and conditions needed to render the implication indefeasible. There might be no systematic characterization of all the necessary qualifications for the goodness of some material inference, some inference that doesn't depend just on logic. Ceteris paribus clauses should be understood as explicitly acknowledging the existence of unspecified defeasors, rather than as somehow turning a defeasible reason into an indefeasible one. Ceteris paribus clauses can't do that. A Latin phrase that could do that would be called a magic spell. And although it's less commonly remarked, incompatibility relations are no less defeasible in general than implications are. The view that defeasible reasons, for or against, must be elliptical for full reasons that are not defeasible is, I think, false, and it's a consequence of commitment to a structural logicism that's contravened by our actual reasoning practices. The response of some philosophers to the empirical prevalence of non-monotonic, non-logical implications has been to develop non-monotonic logics. I think that's a mistake, and not just when it's justified by commitment to an objectionable logicism or structural logicism about reasons in general. The proper task should be understood rather to construct a logic adequate to express non-monotonic implication and incompatibility relations. The distinction between that enterprise and the enterprise of non-monotonic logic is subtle, but it's important. In order to make it visible, I need to motivate logical expressivism. That's the claim that the expressive task distinctive of logical vocabulary as such is to make reason relations of implication and incompatibility explicit in the form of claimable propositional contents of declarative sentences. This is where I'm heading. But first, I want to argue that focusing on monotonicity is already making a kind of a mistake by overlooking other structural conditions on reason relations that are more interesting and important. Monotonicity of implication is a very strong, doubly quantified weakening principle. Monotonicity says that for any arbitrary good implication, gamma implies A, and any arbitrary further sentence B, gamma together with B implies A, is guaranteed also to be a good implication if gamma implies A is. If we take seriously the idea that monotonicity is too strong a constraint on rational consequences generally, there are accordingly two universal quantifiers that might be restricted. We can consider principles that only allow weakening of certain kinds of implications, but not all. And we can consider principles that allow weakening only with certain kinds of sentences, but not all. Containment is a restricted monotonicity principle the first time. It focuses on just one class of implications, those licensed by reflexivity, which says that all implications of the form A implies A are good. Containment, CO, says that all implications of that form can be arbitrarily weakened by any set of additional premises whatsoever. In the idiom I've suggested, CO says that any implication is good whose conclusion, what the implication certifies as part of the implicit content of the premise set, is already part of the explicit content of the premise set. That is one of the premises. This is an antecedently plausible constraint to put on a conception of following from. And as we'll see, it turns out to cut at important joints. But we can weaken the notion of monotonicity along another dimension. Here, I'm representing these things in sequent-calculus forms. The principle called cautious monotonicity quantifies over all implications while restricting what can be added to the premise set by licensing only weakenings that add sentences meeting a special condition. And that condition's defined relative to the original premise set. The plausible idea behind it is while there might be some sentences whose addition to a premise set infirms the implication of some of its consequences, surely it's safe to add to the premise set sentences that are already implied by that premise set. None of the defeasors, the thought is, are going to be things that are already implied by it. What you see on the slide is a Gensen-style sequent-calculus formulation of this rule, which should be read as saying that if all the implications above the horizontal line are good, then so is the implication below the line. Cautious monotonicity says, if you start with the implication gamma A, and it's also gamma implies A, and you also have the implication gamma implies B, then it's safe to add B as an additional premise to gamma. That's not going to interfere with its implication of A. That sentence B is already part of the implicit content of the premise set gamma, implicit in the literal sense of it's implied by it. And since it's in that sense implicit in the premise set already, adding it to gamma as an explicit part of the premise set doesn't subtract or lose you any of the implications. Anything that followed from gamma also follows from gamma together with any of its other consequences, since they're already explicitly contained in it. This condition of cautious monotonicity is weaker than monotonicity. Doesn't say you can weaken with everything, you can only weaken with consequences. I've put up here the sequent-calculus formulation of transitivity, that is of idempotence in the Tarski thing. You see that it's just permuting the different sequence, the different implications, where cautious monotonicity says that adding a consequence never loses any implications. Cumulative transitivity is its converse. It says it never gains any. So CM says that adding consequences never loses any implications, and CT, transitivity, says it never gains any. Now, I want to talk about the notion of explicitation. No, I don't want to do that. Okay. I want to talk about an operation that isn't a logical operation, but is an operation on reason relations of explicitation. If you start with gamma implies A, then I've been talking as though all the premises in gamma are part of the explicit content of gamma. And A, the consequence, is part of the implicit content of that premise set, in the literal sense that it's implied by it. And that means we can understand an operation, what cautious monotonicity and cumulative transitivity are about, of moving something from the one side of the turnstile to the other side, taking a conclusion and exploiting it as another premise. Explicitation, I want to call this, moving something from the side of the turnstile where things are merely implied to its being an explicit premise. This is the structure of inference, of the paradigmatically rational activity of explicitly acknowledging the consequences of one's commitments, using the conclusions one's come to as premises in one's reasoning. Now, the thing is, if you impose the weaker condition, more plausible condition of cautious monotonicity, along with transitivity, so if you relax the condition of monotonicity to this point, it still has the implication that explicitation is inconsequential, that because CM says that explicitation never subtracts consequences from a premise set, and CT says that explicitation never adds consequences to it. Together, they entail that explicitation is inconsequential. Drawing consequences from conclusions that you're entitled to never makes any difference to what other implications, whatever other conclusions you're entitled to. Can we imagine reason relations that don't satisfy this condition? Yes, we can. Looking at the structure of implication relations, from the vantage point of explicitation, is considering the constraints that stem from relations among implications, for that's what explication is. We care about that explicitation relation because it normatively governs attempts to extract consequences from a set of commitments. An explicitation path from a premise set gamma to a sequence of supersets of gamma, each one resulting from the previous one by adding as a premise some consequence of the previous premise set. We're used to thinking of explicitation in this sense as inevitably leading to a foregone conclusion, the same set of consequences, no matter which ones we acknowledge first and which later. The rational closure of a set of premises gamma comprises all of the consequences of gamma. But there is such a thing as the rational closure of a set of consequences only in the special case where CM and CT hold, so that consequence is explicitation closed. In what I'll call hyper-non-monotonic cases, where cautious monotonicity and transitivity are not guaranteed to hold, explicitation paths can diverge. Which conclusions you can reach from some base gamma of premises depends on the order in which you extract consequences from it. Some that are passed over early can become inaccessible. If CM fails, you can lose some consequences later on. This is rational hysteresis, or path dependence. The process of inferring, in the sense of following out an explicitation path, is, in an structurally open setting, an essentially historical one that can lead far afield from its starting point. Now, people disagree about whether believing all the consequences of one's beliefs is really an epistemic ideal. The usual objection is that it's impossible for us poor, finite, forked creatures to do that. Consequence set is too large, some of the conclusions are too distant, and ought implies can. But both parties to that dispute think there's something at least definite to mean by all the consequences of one's beliefs. That's what they argue can or cannot and ought or ought not to be believed. The point I want to make is that whether it even makes sense depends on the structure of the reason relations involved. There's a specifiable boundary between consequence relations for which it does and consequence relations for which it does not so much as make sense. And that boundary is cautious monotonicity and transitivity, what I'm calling explicitation closure. And I want to claim that even the most structurally relaxed of these kinds of reason relations can serve the basic pragmatic function of determining reasons for and against to serve in defenses and challenges of claimings, where a principal criterion of adequacy of doing that is underwriting the isomorphism with truthmaker semantics. But I want to look more closely at two further metatheoretic offices that the concept of reason relations is called upon to carry out. For the logical and semantic formal metavocabularies for talking about reason relations do set reasonably definite criteria of adequacy on conceptions of the structure that characterizes reason relations as such. Can we do logic with radically open structured relations of implication and incompatibility? Do hyper non-monotonic reason relations, those for which even cautious monotonicity fails, allow the definition of a tractable notion of propositional conceptual contents? I hope to show that both these roles, a logical role and a semantic role, can be played by structurally open reason relations as well as structurally closed ones. Reason relations of any structure that can clear those substantial hurdles in logic and semantics will be able to play their role in pragmatics as normatively governing a minimal discursive practice of making, challenging, and defending claims. And those open, both topologically open and explicationally open reason relations will suffice to correlate up to isomorphism the use of sentences described in such a pragmatics with a truthmaker modal mereological account of their meanings. What might be called the reasons question in the philosophy of logic is how logic is related to reasons and reasoning. I've talked about logicism and structural logicism as traditional views. What I'm exploring is an alternative to them, logical expressivism, that says the expressive role characteristic of logical vocabulary is to make explicit reason relations of implication and incompatibility. Well, what does that mean? In my first lecture, I sketched a pragmatic account of a minimal discursive practice in which participants use sentences to assert and deny claimables, which essentially involves rationally defending and challenging claimings with reasons for and against them, which are in turn determined by reason relations of implication and incompatibility among them. By doing what they do, such users of a base vocabulary accordingly practically acknowledge the reason relations that normatively govern their giving and asking for reasons. But they don't have to be able to say what sentences imply or are incompatible with what others. They just practically take some of these relations to hold. Logical vocabulary, as I'm understanding it, gives them the additional expressive power to do that. The idea is that the conditional, if A then B, says that A implies B. And adding negation then makes if A then not B available to express the incompatibility of A and B. Logical vocabulary makes it possible to make reason relations explicit in the sense of sayable, assertable, and deniable, rationally challengeable and defensible declarative sentences. The defining expressive function of conditionals and negations is to codify reason relations in the form of rational propositions, that is, in the form of claimables that can themselves stand in reason relations of implication and incompatibility, both to sentences of the lexicon of the pre-logical base vocabulary and to other logically complex sentences formed from them. They bring the reason relations, conditionals and negation, bring reason relations into the game of giving and asking for reasons as things reasons can be demanded for and given for. We can make this a little bit more precise by using the vocabulary that I've introduced. We can think of, in particular, sequent-calculus versions of specifications of logic as a set of meta-inferential rules that tells us how to derive a larger set of reason relations from a smaller set. That's what the sequent calculus does when it says, if all the sequents above this sequent line are good, if all those are good implications, then so are all the ones below it. In fact, some of the sequent rules are bidirectional. If all the sequents below the line are good, then also all the sequence above the line is good. This is the distinction between derivability and admissibility in the sequent calculus, but it is possible to get some rules that go both ways. So we know syntactically how to extend a base vocabulary to a logical vocabulary. If A is in the lexicon, then we add in the new lexicon not A. If A and B are in it, we add A arrow B, A and B, A or B. We get all these new sentences. What the sequent calculus formulation of logic does is show you how to derive from the reason relations of the base vocabulary what the reason relations of the logically complex sentences are. Normally, logic isn't thought of this way because we think of it as starting with an empty base, a base that just consists of instances of reflexivity. But that's not the way we're going to do it. The point is that the expressivist point is that something like this deduction detachment rule says whenever in the context of gamma on the left and delta on the right, the implication from gamma together with A to B together with delta is a good one, when that implication of B by A in that context is a good one, then in that context, gamma already implies the conditional. And anytime it implies the conditional, that one's good. Rational expressivism about logic, the view that what distinguishes and demarcates logical locutions as such is their expressive role in making reason relations of implication and incompatibility propositionally explicit, both puts constraints on the admissible way of computing the reason relations and sets criteria, norms, desiderata for assessments of the adequacy of particular sets of metalogical sequent rules. First, the logically extended vocabulary must be elaborated from the base vocabulary, in the sense that both the lexicon and the reason relations of the extended vocabulary must be computed from those of the base vocabulary. You don't need anything to know anything except what are the good implications and incompatibilities in the base vocabulary. Second, the logically complex sentences of the extended vocabulary must explicate the reason relations of the base vocabulary, as well as those of the logically extended vocabulary. That deduction detachment rule for the conditional, that should hold. That's what it is for the conditional to say that an implication is good. I'll say that a vocabulary that's conservatively elaborated from and explicative of some base vocabulary is LX for that vocabulary, elaborated from and explicative of. One measure of the rational expressive power of a logic, now understood in a sequent-calculus meta-inferential vocabulary, is then determined by the variety of base vocabularies for which it is LX, from which the sequent rules conservatively elaborated and whose reason relations it explicates. The structural closure conditions on implication relations I talked about earlier provide an appropriate scale on which to measure expressive power so understood. Some logics, as specified by meta-inferential sequent rules, fail to define conservative extensions of any non-monotonic or non-transitive base consequence relations. That's true of Genson's canonical sequence specification of classical logic, his system LK. And even logics that could elaborate and explicate topologically open logics, which fail to satisfy the monotonicity principle MO, might well fail to be LX for logics that are not even explicitation closed, that is, for which cautious monotonicity fails. The expressive ideal along this dimension is a logic that's universally LX, LX for any and all base vocabularies, regardless of the structure of their reason relations. I'm happy to be in a position to share with you the good news that there is, in fact, such a universally LX logic. We call it non-monotonic multisuccedent logic, or NMMS for short. And the sequent-calculus definitions for that logic are at the end of the handout. They don't actually matter. The details, I'm not going to talk about them, but you can look at them there. This logic has three remarkable properties. First, it's expressively complete in an unprecedentedly strong sense. Dan Kaplan showed how to associate each sequent or set of sequence whose premise set and conclusion set consists of logically complex sentences with a set of sequences in the base vocabulary relating only logically atomic sentences that occur in them, such that this arbitrary sequent or set of sequence in the logical supervocabulary hold all and only in the logical elaborations of bases in which that set of atomic sequence holds. In this clear sense, the logically complex sequence say that the corresponding logically atomic sequence hold. For they're derivable just in case those reasons hold in the base vocabulary. Fixing the lexicon of the base vocabulary, we can compute for any set of atomic sequences which logically complex sequence say that just those sequence hold. And for any sequent or set of sequence relating logically complex sentences, we can compute just which base sequence they say hold. This is the precise version of the X dimension, explicative dimension of LXness. For any relations of implication and incompatibility that atomic sentences can stand in, NMMS permits the formulation of a single sequent in the logically elaborated supervocabulary that expresses just those ground level reason relations in the sense that the sequent is derivable just from bases in which those reason relations hold. This expressive completeness result is a more powerful version of the way that in the two-valued semantics for classical logic, truth tables let us go back and forth between the values of logically atomic sentences and those of logically complex ones. It applies to assessments of candidate implications as good or bad, rather than assessments of sentences as true or false. And it's much more powerful in that every finite set of atomic implications in the base vocabulary is represented by a single sequent in the logically extended consequence relation, and every implication in the logically extended consequence relation represents a unique set of atomic implications. The second remarkable property of NMMS is that it's fully tolerant of open structured or even radically substructural base vocabularies. This feature has to do with both the elaboration dimension of LXness and the explication dimension. NMMS conservatively extends logically atomic base vocabularies that are non-monotonic and non-transitive, and even those in which cautious monotonicity fails. This is a substantial achievement because it's easy for meta-inferential rules for connectives to enforce global structure, for instance, monotonicity. An obvious rule would be a left rule for conjunction that says that if, in some context gamma, a premise A implies something, then that same conclusion follows from the conjunction A and B. But within very wide limits, the full expressive completeness result holds for the elaboration of substructural base vocabularies in NMMS. So NMMS is provably universally LX. It elaborates any base vocabulary, no matter its structure, and does so in a way that's expressively complete, providing logical codifications of arbitrary collections of atomic reason relations. The third remarkable property of NMMS is that it's essentially just classical logic. Understanding the sense in which NMMS is classical logic, and also what nevertheless distinguishes them, I think sheds significant light on the interrelations between the topologically and explicitationally open structures of material non-logical reason relations on the one hand, and the expressive task distinctive of logical locutions on the other. The first data point in understanding the intimate relations between classical logic and NMMS is this. In the fully topologically closed setting, defined by Gensen's full set of structural rules, which satisfy the Tarski topological closure conditions, NMMS yields exactly the same logically valid sequence as Gensen's sequent-calculus version of classical logic, LK. In this sense, there are many equivalent sequent-calculus formulations of classical logic, different ways of defining the logical connectives that yield exactly the same logical reason relations, good logical sequence. As soon as we relax the structural requirements of topological closure, however, these hitherto equivalent formulations come apart. Differences among them that don't matter in closed structures turn out to make a difference to what consequence relations they codify in open structured settings. The second data point in understanding the intimate relations between classical logic and NMMS is that NMMS is supraclassical when applied to any base vocabularies that include all instances of containment, regardless of what other structural principles do or do not hold. That is, all classically valid implications and incompatibilities are included in the NMMS elaboration of every base vocabulary that includes as good all sequence where some premise is included in the conclusion set. This takes us a step beyond the first point, that if those CO instances are the only good implications in the base vocabulary, then NMMS validates all and only classically valid reason relations. So, out of all of the variant ways of introducing the connectives of classical logic in the sequent calculus, hundreds of them, NMMS is one that not only degrades gracefully, but continues to work fully, is expressively complete when we move from structurally closed to topologically and even explicitationally open settings. In those settings, NMMS still elaborates base vocabularies conservatively. It's supraclassical if those base vocabularies satisfy containment and yields exactly the classically valid implications and incompatibilities if it's applied to base vocabularies, all of whose implications are instances of containment. And in all these open structured and closed settings, all these substructural settings, it remains expressively complete in the Kaplan sense. For every set of atomic base sequence, there's a unique logically complex sequence that's derivable just in case the base vocabulary to which it's applied contains those atomic sequences, and vice versa. Okay, my aim here has been to demonstrate the benefits from a change in perspective of thinking about logic. And here, if you're willing to take my word for the details about how the logic works, what matters is what it'll do. What matters most about a logic from the expressivist point of view is not its theorems or even its consequence or inconsistency relation. That is, the logical reason relations the logic gives rise to and enforces. What matters most about a logic is the expressive power it affords to make explicit a variety of material reason relations of non-logical vocabularies. In our regimentation, particular implications and incompatibilities defined in non-logical lexicons are codified as logically complex sentences in extensions of those vocabularies whose reason relations are defined by meta-inferential rules in a sequent-calculus metavocabulary. The right logic can make explicit the reason relations of any and every base vocabulary, even those with the most minimal structure. And the practical expressive capacities afforded by logical connectives, even of less expressively powerful logics, are transformative for language users. We can compare two linguistic communities, one of which asserts and denies and challenges and defends the resulting commitments according to the reason relations of a non-logical base vocabulary. We can compare such a community with one that works with the same lexicon and reason relations, but of the logically extended vocabulary computed from that base. The first group of speakers, ones I talked about in my first lecture, is rational. They can not just respond differentially to things, they can respond by making claims and judgments. They can give and assess reasons for and against their claims and objections. But they can only disagree about and critically assess the credentials of doxastic commitments, manifestable as assertions and denials. They can't make claims about or assess the credentials of the implications and incompatibilities they implicitly appeal to in their reasoning. They're rational, but not self-consciously rational. What they're lacking is logic, which at base is an organ of rational self-consciousness. What confers that power is the full logically extended consequence and incompatibility relations, precisely because they relate logically complex sentences that do not codify reason relations that hold in virtue of logic alone. Conditionals such as, if it's raining, then the streets will be wet, that codify material proprieties of inference. The purely logical reason relations articulate the content of the logical locutions, and that's important. But the logically extended vocabulary articulates the contents of the non-logical locutions of the base vocabulary, and that's much more important. We can define what it is for some implications and incompatibilities in the logically extended supervocabulary to hold in virtue of logic alone. Now, NMMS has been carefully sculpted to extend our open structured material consequence relations conservatively, even in bases that are hyper non-monotonic, where cautious monotonicity fails. But the astonishing fact is that the purely logical part of any NMS extended base vocabulary is guaranteed to be fully structural and topologically closed, monotonic, transitive, and idempotent. In this sense, NMMS is not a non-monotonic logic. It's a monotonic, structurally classical logic for codifying non-monotonic consequence relations, including the ones in which CM fails. Looking back from the point of view of rational expressivism about logic, the thesis that the expressive role that distinguishes specifically logical vocabulary is making reason relations explicit, the logical tradition of the past 100 years or so can be seen to have made two large mistakes. The first is a version of the one made by the drunk who looks for his keys under the street lamp rather than across the road where he thinks he dropped them, because the light's better there. In this application, the metaphor, the bright light, is the clarity, perspicuity, and tractability of classical logic under the traditional bivalent semantic interpretation. The role of the keys is played by the codification of reason relations. Logicism about reasons is the view that reason relations must be codifiable by that spectacularly well-behaved classical logic. The second mistake is subtler. When logicians did take seriously the existence of substructural or open-structured reason relations, the form their efforts took to codify them was logics whose own reason relations were substructural, non-monotonic logics. For if reason relations are at base logical reason relations, as logicism claims, then there must be open-structured logical reason relations behind those open-structured material reason relations. That is, the motivation for non-monotonic logics involves keeping logicism and giving up structural logicism. Expressivists do it the other way around, for we've discovered we can split the difference by codifying radically open-structured reason relations with a logic, NMMS, whose own logical implication and incompatibility relations are topologically closed, just like those of the classical logic of which it's a version. Further, that universally LX logic is superclassical and collapses to classical logic when applied to a flat prior, in the sense of a base vocabulary that consists only of CO instances. In my first lecture, I introduced the idea of reason relations, of implication and incompatibility, and offered two sorts of explanations of them, one in bilateral pragmatic deontic normative terms, and the other in truth makers semantic alethic modal terms. One of my basic claims is that the minimal structural conditions on rational relations of consequence and incompatibility are much weaker than has traditionally been supposed. This time, I addressed the question of whether, to what extent, and in what sense, radically substructural reason relations deserve to be thought of as genuine reason relations of implication and incompatibility. And I've shown here that they pass one test that's crucial for logical expressivists. Substructural reason relations can be codified completely by a very well-behaved logical vocabulary, indeed by what is, in several real and important senses, just classical logical vocabulary. The next task is to investigate what sort of conception of rational propositional content results from considering the role that declarative sentences play in radically open structured reason relations. Next time, I'll show how a full-blown implication space formal semantics incorporating a tractable concept of proposition can be elaborated from just such substructural vocabularies, in the spare technical sense in which I've been using the term, a lexicon together with a set of reason relations. The first criterion of adequacy that semantics must satisfy is that it provide a sound and complete semantics for the universally LX logic NMMS. I'm not going to do that, but I'll tell you we do have that. And it turns out that result can be generalized to many other logics as well. Our ultimate interest, though, will be in what implication space semantics can teach us about the relations between meaning or propositional content and reason relations. That's my topic for next time. Thank you.
Thank you for this excellent lecture. Any questions?
Thank you, Professor Brandom, for this highly fascinating talk. I was wondering if the same result we have for standard sequent-calculus, that if we restrict them to single sequent-succedents, you get an intuitionistic logic instead of a classical logic. That still holds when we move to NMMS. And if so, what motivates the choice of going multi-sequent multi-succedent and thus getting a classical logic instead?
Okay, good. Yeah, there is a single sequent supra-intuitionistic version of NMMS. You can sort of figure out what it is by looking at the multisuccedent rules. And that's where we started, actually, because notoriously the single succedent sequence correspond to implication, sort of our usual sense of implication, better than the multisuccedent do. I mean, you will have noticed that last time I appealed to Restall's account of how to make sense of multisuccedent sequence. What our collaborator Dan Kaplan realized is that the benefit of going multisuccedent is you can get this very powerful expressive completeness result. There is not an analog of that for the single succedent superintuitionistic version. And this actually drove us all the way back to thinking about the reason relations in a bilateral way so that we could help ourselves to Restall's understanding of what was going on. So it's exactly this point of getting the powerful expressive completeness that drove us to the multisuccedent setting. And yeah, apparently classical logic has these advantages. Who knew? As I say, we started off with something that philosophically is more intuitionist.
Yeah. Any further questions? Niklas?
I have yet another one, if I may.
Yes, also, if remote viewers have questions, please write them in the chat and I'll be bored soon.
So this question is more speculative, and it has to do, so when you mentioned that you wanted the logic to be universally LX, I immediately started thinking of whether there's a way of making sense of this in terms of categorically universal properties. And it seems like there's a natural categorical interpretation of what's going on in terms of the logics you're constructing as a kind of endo-functor on the category of vocabularies, with the morphisms between vocabularies being sort of inclusion on both implication set and the sentences. So I'm wondering if you've looked at sort of the structures coming up here. Does this functor have a universal property in the category of endo-functors on vocabularies?
Okay, that specific question I can't answer, but we absolutely have looked at this. So, in general, I'm reporting the results of our role group, Research on Logical Expressivism is the name of it, that Ulf Lobel is a member of Dan Kaplan, who got this result. Also, Chris Brown, who is a category theorist, has joined us in the last year, and he's very interested in these category theoretic formulations. But where we found the category theory to be most helpful is actually in understanding the implication space semantics rather than starting from the logic. If you formulate the implication space semantics in a category theoretic way, you can understand the logics from them. But so far, that seems to be a better place for applying that apparatus. But our general thinking about substructural reason relations is something that we're keen to explore the results that we'll get by thinking about category theoretically. But other than Chris Brown, none of the rest of us have the sort of control of that apparatus needed for us to do it. So he's bringing us these shiny gems for us to admire. But that's a project that's in early days.
Thank you. We have a question from remote viewer Virginia Sorrell.
Hello. Could I put my video on as well?
Not sure I can do that.
Okay. Well, I'm sorry. So I will just be a voice. So thank you for your talk. And I had a question concerning basically your project. So I'm not that familiar with your work in philosophy of logic. It may be a very naive question, but first of all, I wanted to make sure that I understood where you were going. So what I understood is that for you, logic normatively govern users' commitments. And that would mean that your investigation of the logical structures of reason relations, regulates and maybe even creates intersubjective commitment. Is that all right?
I would put it by saying that it's the reason relations that articulate propositional content, and the practices of challenging and defending That's what creates an intersubjective propositional content. And then logic comes on the scene and lets practitioners for the first time talk about those reason relations, those semantogenic reason relations, to make them explicit.
Okay, so it's not logic that makes explicit the normative power of commitments.
Right. I would say deontic, pragmatic metavocabulary is what makes explicit the normative dimension of discourse. The sort of pragmatic metavocabulary I used last time that uses concepts like commitment, entitlement, preclusion from entitlement.
Okay, so in that sense, logic is just a tool because it's not the thing, if you want, that gives the normative power. It is just
right. It's not determining what's a reason for or against what. It's just giving us the capacity to say what's a reason for and against what.
Okay, thank you.
Next up is Frank.
Oops, sorry. Okay, I was lost here for a second. Thanks again. Question is this, because I hear so much about the reason relations of implication and incompatibility. I now wonder, do we really need more than these two? So something like, is a sufficient reason for, is another a necessary reason? Or can we really do everything with just these two relations? They seem to be the main players in your talk so far.
Right. Well, of course, we're very interested in, it would be remarkable if logical expressivists coming late in the logical tradition said, look, we haven't properly understood what logic's about. It's not about settling what's a good reason. It's about saying what's a good reason. It would be remarkable if logicians working with the old conception had in fact found sort of all the vocabulary that was needed if you just tweaked it properly. So we're very interested in what other sorts of expressive capacities with respect to reason relations we can introduce vocabulary to explicate. And in the book, we retail some results, again, due to Dan Kaplan, about how to codify structural features of the reason relations that are not universal. So suppose we've got a set of material base implication relations that include non-monotonic inferences. So, we can make the inference from it's raining, so the streets will be wet, but there's all sorts of additional premises that could defeat that implication. There are going to be, nonetheless, inferences like Pedro is a donkey, so Pedro is a mammal, that are non-monotonic. So it doesn't matter what additional premises you throw in. It follows from him being a donkey that he's a mammal. We can introduce operators, they behave a lot like modal operators, that explicitly mark local regions of monotonicity within a sea of material implications that in general are not monotonic. We can mark the ones that are. We can say that Pedro is a donkey doesn't just imply Pedro is a mammal, it implies necessarily Pedro is a mammal. Well, anyway, a box, Pedro is a mammal. Non-monotonicity can be codified that way. Full classicality, monotonicity plus transitivity. We can introduce an operator that will distinguish sentences in the logically extended lexicon that codify classical and monotonic implications. So there are further kinds of expressive power that count as logical in our sense, which we can introduce. The ones we're particularly interested in are to codify islands of closed structurality within the sea of non-monotonic material implications. Is that a responsive answer?
Yeah, thanks very much. Thank you.
Okay, next up is Jakob.
All right, thank you very much, Professor Brandom. So I would be interested to know a little bit about the implications, logical expressivism, or expressivism about logic, either way. What implications it has for generally on philosophy of logic, for example, or in particular, there's been a lot of talk in recent years about the so-called adoption problem in the philosophy of logic, which derives from Kripke's work. I'm sure you've heard of it. But basically, the adoption problem states that roughly that it is impossible to rationally come to accept some basic logical rules, such as the universal instantiation, because if you can already reason logically, but you haven't already accepted the, for example, universal instantiation rule, then you can't. There's no argument possible that could make you rationally accept it. So, yeah, there's of course more to it, but I was wondering, does expressivism offer some potential for solving this problem? For
well, not in its terms, because the rational expressivist gets off the bus before the problem before the adoption problem can really be stated. That is, the bit of Kripke that this comes from, it involves his, I would say, struggling with the idea that what's fundamental is material relations of implication and incompatibility. The ones that make our non-logical concepts mean what they mean. The sort of implication, Pittsburgh is to the west of New York, so New York is to the east of Pittsburgh. It's licensing inferences like that that articulate the content of non-logical concepts like east and west. That's where things bottom out for us logical expressivists. We can give a pragmatic account of what it is to take or treat these implications as being good. We can give a semantic account of what it is for them to be good, but it's all the material inferences. On that basis, then, you can introduce many logics. The sequent-calculus will allow us to do that, and you stipulate which principles govern the use of your logically elaborated sentences. Logical expressivism is essentially pluralist. It denies the notion of the correct logic. It looks at different logics as in terms of the features of reason relations that they codify. There can't be a knockdown dispositive argument for using one logical vocabulary rather than another. For instance, one that has a classical logical principle rather than a intuitionist one. The question is, which features of reason relations is it that this logic makes explicit? I gave a general sort of normative framework for saying better or worse in its expressive capacity, but the classical horseshoe makes explicit the sense of good inference in which something is not a good inference if it has true premises and a false conclusion. That's not a very important good-making feature, but it's worth marking. The intuitionistic conditional makes explicit the sense of good implication in which it's an implication is good if there's a recipe for turning an argument for its premise into an argument for its conclusion. The hook of strict implication makes explicit the sense of good implication, in which an implication is good if it's impossible that its premises be true and its conclusion not be true, and so on. So in this radically pluralistic picture, the question of reasons compelling you to adopt a certain principle simply doesn't arise. So as I say, I think of us as getting off the bus before that question can arise.
Thank you. Any final questions? All right. Thank you for this lecture. See you tomorrow.
Well, thank you. I'm looking forward to it.